quadratic, that means it's an x squared. It always has a parabola or like a U-shaped graph. Axis of symmetry. How do you write the equation of an axis of symmetry? What is the axis of symmetry?
Is it where the thing, the line where the thing hits?
It's the line that goes through the center. Hello.
Bye.
So nice. So, what's the equation of a vertical line?
0.
Is it x equals or y equals? Let me ask that. X equals. So, if I ask for the axis of symmetry, it's a line, so you have to give me the equation of a line. So you have to say the x equals. And then we're just looking at what is the x value right there.
1, 2.
Negative. We went backwards. It was a page that I had skipped before. I was saving it as a review. All right, so axis of symmetry, vertical line going through the center, x equals negative 2. All right, for graph B, so we have to find, what's this point called? Do you remember? Starts with a V. Vertex. All right, what's the axis of symmetry, the vertical line going through the vertex on graph B?
3.
So we would write it as x equals 3. All right, what is the vertex of graph A? The vertex is that ordered pair. So the x is negative 2. What's the y? Negative 5. Is that a maximum or a minimum value? Minimum, because it is the lowest point on the entire graph. All right, next question. What's the vertex of graph B? So what's this ordered pair?
4.
3, 4. Is that a maximum or a minimum? All right. Looking at graph A, domain and range. What is the domain of every one of these? Okay, the range of graph A. It started at this and went up. So range is y. We would say,
Y is greater than or equal to 2.
what's the y value here? Negative 5. So y is greater than or equal to negative 5. All right, what's the graph, or the domain on graph B? All real numbers. The range, this one hit everything below.
So y is also equal to 2.
Now, I have to pick the equation for graph A. Can you tell me if graph A had a positive or a negative x squared? How do we know if it's positive or negative? Yeah, if it's going up or down. Remember, if it's an upward facing parabola, that was a positive. But if you put a negative in front, it flips upside down. So graph A had to be a positive x squared. So I can definitely narrow down. Choices C and D are out. Do you remember how to find the axis of symmetry? We had an equation that we used. Was x equals the opposite of B 2a. We know that for graph A, the axis of symmetry should be x equals negative 2. Let's check what the axis of symmetry would be from these equations. So for graph A, the opposite of B, what's my B value? Negative 4. So the opposite of negative 4 would be positive 4. over 2 times, what's my a value? Just a positive 1, because it's the number in front of x squared. 4 over 2 equals 2. Is that correct? Is that what it should have been? Very first question we said it was x equals negative 2. Let's check for b. The opposite of b, so the opposite of 4 is negative 4 over 2 times a, which is 1. And we get negative 2, and that was correct. So b is the correct equation for that graph. On the EOC, let's say they asked you this question. It was a multiple choice like that. How else could you narrow it down? What could you do? Staring at your calculator. Can you graph all 4 of these on your graphing calculator and see which one matches? Absolutely. Use your resources, okay? If I look at graph B, is it a positive or a negative x squared? Negative because it opens down. So I know it's not A or B. The axis of symmetry on that one is supposed to be x equals 3. So let's check it. If I did C, what's my B value? A is negative 1, B is negative 6. So the opposite of B will be a positive 6 over 2 times A, which is negative 1. 6 divided by negative 2 is negative 3. Is that what we said it should be? We said it should be positive. So that can't be right. On D, what is my A? Negative 1. What's my B? So let's check that one. Opposite of B, that would be a negative 6 over 2 times negative 1. Negative 6 divided by negative 2 is positive 3. Is that what we said the axis of symmetry should be? Yes. And again, did you have to do it that way? No. You could have used a graph to help narrow it down. All right. Questions on that? So let's do some more review. Tomorrow, we're not, normally I would give a quiz over this, but because we just had break, that would be kind of rude to come bring you back after a week and give you a quiz. But we're going to do the quiz that we would have done as like in-class individual work tomorrow, so you can ask me questions. Look in your notes, but you can't work with a partner. But I'm going to do some review, and if it were me, I would probably write this down. It might be very helpful to you tomorrow when you're trying to work on these. So have that to reference. So we're going to do a couple problems. And let's say I gave you y equals 2. Oh, let's do this. 2x squared minus 8x minus 3. If I asked you for the axis of symmetry, what would we do? Opposite of b over 2a. What is the a in this problem? And what's our b? Negative 8. We don't need it here, but c would be the negative 3. So opposite of b, opposite of negative 8 would be positive 8 over 2 times 2. So 8 over 4 equals 2. How do we find the vertex? Plug it in. You can use your calculator. You don't have to do it by hand. We're just plugging in that 2 for our x. So what do we get? You guys tell me what that turns out to be. -11. Okay, so how do I write my actual vertex? It's that point to -11. Right. If I asked you to graph it, we usually made a t-chart. And remember we had like 5 values we would put in? And what did we do with our vertex? Put it in the middle. And then we went to the table on our calculator to get some other points. So everybody do that with me. You go to your y equals, clear out anything that's there. We're going to type in 2x squared minus 8x minus 3. And then we go into the table. So we have 0, -3, 1, -9, 2, -11, 3, -9, 4, -3. So if I asked you to graph it, you're just plotting those points. 2, -11 is the vertex. We have 0, -3, 1, -9, 2, -11, 3, -9, 4, -3. You could draw the axis of symmetry, just that vertical line going through there. We know it should be the same on both sides. So it looks like this. What is the domain of that? All real numbers. What's the range? Greater than or equal to -11. Okay, so if I gave you problems like that, the key thing is remembering axis of symmetry. X equals -b/2a. And then you should be able to get your graph from there. Are there any questions about those types? Okay, the second thing we did was all the same stuff, but we had transformations. So the second piece today, I just want to review our transformation rules. Remember, the parent function is always x squared, like your original. And I strongly encourage you to write this down. If you ask me for this part tomorrow, I'm probably not going to tell it to you again because we just wrote it down today. So let's just talk about some different equations. If I said x squared plus 2, what does that plus 2 do to my graph? It's on the end. So on the end is changing y, so that's up or down. And y does what we think, so it goes up 2. It's been a while. But you can always double check that. You know, a quadratic normally looks like this. If you graph x squared plus 2 on your graph, on your calculator, it just moves the whole thing up. Same thing, just shift it up. So if I gave you, oops, y equals x squared minus 2. What would that 2 do? Down 2. So if it's on the end, just a plus or minus on the end, it would move it up or down. Then we might see it on the inside. Inside changes x. So I told you if you add to x, it goes to the left. So this would move it left 2. So if I subtract on my x, it would move it right 2. All right. So that's how we move left, right, up, or down. Do you guys see the difference between when it moves up and down and when it moves left and right? If it's inside parentheses, that's the left and right. If it's just tacked on the end, that's the up and down. All right. What happens if I put a negative out in front? It flips it. We know that makes it open down, so it's now upside down. So that means flip or reflect over the x-axis. So negatives are flipping. And the final thing we talked about was if I'm multiplying. All right, so let's look at these. One of them I'm going to multiply by 2/5, one of them I'm going to multiply by 5/2. All right, we know we're not moving up or down, left or right, because we're not adding anything or subtracting anything. The example I gave you was like taking a rubber band and stretching it, right? If I multiply by 2/5, by 5/2, that's like 2.5. So I'm saying, okay, I'm going to make it 2.5 times as tall as it was. What does that do to our graph?
Makes it thinner.
Yeah, you stretch it up, so it's like you hold the bottom and you stretch it up so it gets thin, tall and skinny. So we call that a vertical stretch. In terms of what the graph does, it's tall and skinny. Because we're just stretching it. If you multiply by 2/5, 2/5 is less than 1. It's like 0.4. So I'm saying, okay, I'm going to take the height times 0.4. What does that do to my graph? Shrinks it. Okay, it's like shrinking it down. So we can call it a shrink or a compression. Okay, what that does to our graph, it makes it get short and fat. Because you're taking your height and compressing it down. So that's really where we were at on Tuesday, working with these transformations. Are there any questions on those? And everybody has this written down for tomorrow, because you're going to want it then. Okay, so what I want to do now is just practice the transformations today. So I'm not going to have you drawing any graphs, although you could certainly use your graphing calculator. If you're not sure, you could look at your graph. You know what a normal parabola looks like, and you could check. I want to give this out, and then I want to talk about what you do on each piece, okay? All right. The front side. Tell me. All right, so for the front side, it says to cut and paste, but we are not going to do that. That just is extra time. So at the bottom are all the different transformations, and you'll see like reflect across the x-axis is on there. 5 or 6 different times. That means 5 or 6 of these graphs are going to do that. So what I want you to do is you will have a function, and underneath it there might be 1 or 2 or 3 boxes, depending on how many transformations it has. I want you to write in the box what you're going to do. So for instance, if we looked at the very last one, number 15, what would that 1/4 do? If it's bigger than 1, it stretches. If it's smaller than 1, it would compress. So vertical compression. So I write vertical compression. You can abbreviate a little bit. 15. So everybody should be writing that down. Vertical compression. And you can mark off now one of your vertical compressions on the bottom. So you're going to use all those choices. And we know we've used one. All right, the next thing, you have an x plus 1. What will that plus 1 do? If it's on the end, it goes up and down. If it's inside, it goes left. So the next thing it will do is go left. So the box underneath, you can say left. You can tell me left 1 if you want, or just left. And you can mark off a left. So the first box we said vertical compression, the next one we said left. And what's the last transformation on that one? Down 3. So we have a down, and you can mark off one of your downs. All right, so every empty box gets a transformation. The ones at the bottom will all be used. Does that make sense to everybody? And then the back side is just matching. There are A through R are your equations, 1 through 18 are your transformations. You just match them up. So you have time to work on that now and ask questions.
So if you're multiplying by something, it's either a stretch or a compression. How do we know which it is? If you take your height times 6, are you getting taller or shorter? Taller, because it's 6 times that. So if the number is bigger than one, it's stretching. If it's smaller than one, it's compressing. You okay?
So would this be stretch?
3/8 is less than 1, so that would be a compression.
Okay.
Yes. It would be a reflection if you're multiplying by something.